Hey everyone, this is FixReef, and today we have an AI Hydra 26. I believe this is an HD version that came in for repair after a previous repair attempt. The claim is that it's water damaged and some pads have been damaged and came off of the main board. So I'm not even going to attempt to plug it in to see what's going on. I'm just going to go ahead and start disassembling. These lights are tricky to take apart, and I suspect that part of the damage is when somebody tried to take it apart and broke off some of the connectors. So let's see what's inside. Okay, so right away we see that the fan's been disconnected, so somebody was definitely inside the slide before. Let's take this off. Otherwise, it looks clean. I'm not seeing a whole lot yet, but then again, I don't see the inside of the board, so we better start removing the connector board here. And that's what's really tough here. As you can see, each, well, this board's connected through a series of pins over here. So there are female connectors, 1, 2, 3, 4, 5, 6, 7, 8, 9. I think about 9 or so of these connectors here. And if you just try to pull it off, you're likely going to break them. So we're going to gently, taking time, start taking it apart. You have to go around the entire perimeter and very gently pull every single one of them off, just a few millimeters at a time. I can already see that this connector is moving, so this connector is off the board. That's not good. Oh boy, this connector is entirely off the board right now. And it's fairly tough to actually have it repaired because these connectors are there are many pins connected to the main board, and the main board is kind of flimsy, or the connector board, I should say. So as you start fixing it, you'll realize that many pins are just very tough to put back in place. Okay. Okay. And it came off. Well, let's see the damage. First off, to make sure that you can actually see this, this female header over here is completely detached from the connector board. That's where it's supposed to be, connected to this, and it's completely gone. I have to assume that this is where the water damage came in as well, because I see some something missing here. Let's see what else. We'll get back to the connector board in a minute. Oh, this one is also missing. Not missing, but completely off the the connector board. This female header too. Wonderful. Other than that, the main board doesn't seem to be too bad. I will plug it in a minute to just make sure that it all checks out, but it's not too bad. I don't see any issues with the LED clusters as well, although I will have to check each individual LED in a minute and make sure that they all run. So let's put this away and let's focus on the connector board, because I think that's where the majority of the damage is. I'm going to go ahead and remove the Wi-Fi module temporarily. It's also Um, these connectors are also off the board as well. So let's get under the microscope. Let's see what we deal with. So currently we're looking at the connectors for the Wi-Fi module. Oh yeah. So this pin over here is off the board, and it's funny how it's still connected to the trace, and the trace is lifted. This pin seems to be all right. There is corrosion on this pin, and who knows what's going on with the trace underneath. Although I believe there is a trace on here that is not being used. Hopefully that's that one. On the other side of this, it seems to be mostly clean. This is where the corrosion happened. You would need to make sure that's all covered, and because this is open copper, it will corrode further if you don't seal it. So, but yeah, so there is that. There is this. This seems to be in a pretty good shape. So that's Wi-Fi module. This connector seems to be in a fairly decent shape. This big connector, kind of hard to tell. It looks like some pins have been disconnected or barely connected. I would have to run through all of them with a soldering gun to make sure that they have proper connectivity. I think this is the factory soldering job that's not perfect in this particular case, but nothing bad. Going down to another connector again, seems to be pretty well. There is some corrosion under this, although the connector seems to be okay, but there is corrosion under this, so I may have to remove this connector and clear up the corrosion. Now we're getting towards the fan circuitry. Quite a bit of corrosion on this one. Again, nothing horrible, but something that probably needs to be cleaned up. The fan circuitry is fairly bad. There is salt, quite a bit of damage. This is all corrosion related damage. Look at how all of this is peeling. Okay. Corroded off connection to this resistor. This capacitor is pretty much completely gone. This is the voltage regulator, and on that voltage regulator it looks like pins are missing. At least one, two pins are probably missing here. This is probably a small MOSFET. Again, a pin is completely missing. And this is the connector that was left on the main board. And over here we see quite a bit of corrosion, but pads seem to be okay. Okay, so the fan circuitry needs to be restored. Moving further, again a little bit of corrosion on these pins, but nothing bad. And this connector seems to be pretty good. Now let's take a look at the connectors that we have. There's corrosion on the inside there, as well as missing pins. So on this one pin is missing over here. And on the other one, there is also corrosion, and one pin is missing right in the middle. So these two connectors are probably no good. Okay, so far, quite a bit of corrosion on the connector board. A couple of these connectors will have to be replaced. The fan circuitry will need to be restored, and maybe a few things cleaned up and sealed off properly, but that's that. Now onto the main board. None of the work with the connector board is going to be worth it if the main board is damaged beyond repair. And in this case, in this specific case, I'm mostly looking at the main controller. So let's plug it in and find out if the amperage draw is proper and nothing's shorted. So let's plug it into my bench power supply. I'll give it a little bit of current, but not a whole lot. The light is on. It's consuming very little power, but it is consuming some. I'm gonna guess that for the most part, this board is probably going to be okay. Okay, so to actually test whether or not this setup with a fixed connector board is going to work, I'm going to test it with a perfectly functional connector board. I have one off of a donor, which is in a very, very good shape. It's practically looks brand new anyway. So I'm just gonna plug it in. This is my test connector board. I'm gonna plug it in, see if this makes the light to light up. And if it does, then all we need to do is just fix the connector board and we're done. The fan. Okay, let's see if this lights up. Okay, the fan is on briefly, and then it's in the blue setting. Yeah, I think it's in the completely reset mode. I think that the previous owner just reset that light. So I think we should be in a pretty good shape. Pulsing blue means that it's not initialized and it requires programming. I also just checked. This light shows up in Wi-Fi settings in the app, so I think it's all good. Okay, so all we need to do is just fix the damaged connector board and the fan circuit. Okay, so let's start cleaning this up. First off, it looks like we need to clean up a couple of disconnectors that are loose. So get those cleaned up, and then we'll get to the fan circuit. Okay, so in this case, the questionable would be this pad over here that looks like it's partially corroded and gone. Let's actually see if we can get some of this corrosion off before we even do anything else. Okay, there is I think enough of good copper in here to attach to. Everything else is just minor. Okay, let's clean this up. I'll use lots of flux to okay, one part at a time. Let's go. And now on to the next one. This one's not really damaged significantly. It's just the connector's gone with all of the pads still intact. And there is not a whole lot of corrosion here either. It's just a matter of removing all of the old solder and replacing it with this fresh one. Okay, and last but not least, this connector that's been damaged and one of the pads lifted. I especially do not like this one over here. So I'm actually thinking about removing this connector, potentially even replacing it, because I need to clean up all of this mess underneath. So why don't we just remove it instead of just cleaning up? I'll just use some flux around to help me remove the solder. Okay, the connector is out. It's actually out in one piece. I may be able to reuse it, but it all depends on the condition. Now, there is a lot of corrosion on this pin. Let's see if we can clean this up. I also found that one of the other pins was lifted too, but not a whole lot of damage there. This pin is still okay, or the pad rather. Lots of corrosion, but I think whoever owns this light got it just in time for me. A little bit more, a little bit longer, and it would have completely eaten away those pads. So far so good. So now we have three of this. Let me zoom in. So now we have three of the connectors removed. Two of them were already gone when I opened the light, and I just carefully removed this connector. There is only one pad here that's really lifted bad, and there is one more pad that's partially lifted. I think one of these two. I'll have to see. But other than that, this doesn't actually look too bad. It's salvageable. Also, good news is that these pads are all salvageable too, and they will work. Now, we need to clean this up. Hey, check out the condition. This is not bad at all. This is not bad at all. Okay, so the next thing is going to be the fan circuitry. Most of the components are kind of gone. One of the capacitors already disconnected as I was from just me handling the board. There was a capacitor over here, so there are a few more components here that I'm gonna just completely remove, salvage what I need to, replace what I have to. Such a mess. Okay, let's start. Bit of flux all over the place, because every single component here will have to go. Okay, we can always start with this resistor. gone. How about this resistor over here? Gone. How about this little module here? It's probably not held by much. Yeah, look at all of this mess. Lots of rust came off. Okay, time to clean it up. A lot more flux. Okay, at this point I have absolutely no idea how many pads are actually alive and exist under there, so we'll need to do some good cleaning and find out. Okay, I see a lot of shine. That's good. Let's take a closer look. So from just this here, I would imagine that there is a pad. There is a pad over here that's completely gone. It looks like this pad is mostly gone, although I'll need to take a closer look under the microscope. Probably is. Then there is these two pads for the capacitor are perfectly good, or maybe not. Actually, this is questionable as well, although I think it has better chance than many. Let's see, this pad over here for this capacitor seems to also be gone. The pads for this large component over here, this pad is probably gone. The MOSFET pads seem to be intact, and the diode pads seem to be okay. Okay, so let's look again under the microscope. Okay, that's much easier to see. Okay, so over here we're supposed to have a resistor. This pad is completely gone, but the good news is that it looks like this is the trace, and it's right nearby, so we can probably just run the jumper wire to connect to it. Not a big deal. Over here, this looks to me that actually some of this trace is gone. Hopefully you can see this, but this trace kind of ends here, where there is this copper. So that's all gone. It's supposed to lead to this pad that's supposed to provide access to the this other resistor. So we'll have to restore that with a jumper wire. This pad I actually didn't clean up too well, so let's do that again. but I think that this path for the capacitor is actually okay. Yes, this one's definitely okay. So there's supposed to be a capacitor over here, and the path for this capacitor is completely gone. It's supposed to be here, but the good news is that we have a little bit of the trace available here that goes into a via. It's very important to ensure that this via is actually conducting, but um, we'll need to connect to this via. Then this trace is supposed to go to this component over here, and the path for this component is gone, but the traces around it are available. This trace is actually still good for the MOSFET. Half of it is gone, but it'll be okay. And this trace for the diode is also okay. Okay, overall not too bad. All right, now let's add some fresh solder to all of this. Okay, so let's start with the resistors. Let me show you what or why we have to replace these resistors. So for example, let me actually get the one that belongs here. This is the resistor I just took off of here. Now this resistor seems to be okay, and it probably is. The problem is that because this pad is gone, the pad it was sitting on this side is also gone. You can see that one side is shiny, the other one is all rusted off. So we cannot really reuse this resistor now. So we need to find a replacement for it. So I luckily have plenty of those off of the donor boards. So we're just gonna go ahead and have it installed. Beautiful. Now, of course, the problem is that this is not currently connected to the trace because the pad is gone. So we'll use a jumper wire. And that's it. This will hold it real well, and it will be good enough to conduct whatever current it requires. Okay. The next one, I'm gonna install this capacitor that's easy to install. This capacitor is still quite good. I tested it, and it works. Okay, next, I think I will install the second resistor. Once again, this resistor has been significantly damaged, the original one anyway, so we're gonna have to put a replacement in. And of course, the problem is that the replacement is lacking the pad, or the original place is lacking the pad for the replacement. Which is okay. We'll do what we did before. So we just need to run another jumper wire across. Next, let's install the other capacitor. This capacitor will also have a bad pad. Of course, the capacitor will be a replacement because the original capacitor was completely rusted off. Okay. Now this will require a double trace, primarily because the jumper wire from here is missing, and then the pad is missing on the op amp. So we'll connect the wire to the via. That's because that's where it belongs. Then have it hooked up to the capacitor. And now with the capacitor installed and the jumper wire run, it's time to install the op amp. Next, I will need the MOSFET. I actually have some of these MOSFETs brand new. Of course, the challenge here again is that the pad is missing. Alright, and this trace is now restored. Alright, and the last thing would be the diode. Okay, let's get a new diode for this. It's gonna be a slightly smaller size, but it should still work. Okay, so the fan circuit has been repaired. It's in a mess, so it's time to clean it up. Hey, it doesn't look too bad once cleaned up. Doesn't look too bad at all. So this is what it looks like after it has been fully cleaned up, and it does not look bad at all. So one of the concerns I'm having here is the via that I used to attach one of the jumper wires to, specifically this one over here. Now, if this via is somehow damaged and corroded, then none of this is going to work. So before I continue, I want to make sure that this via actually contacts, and it does. Excellent. I think we have a restored fan circuit now. Just a little bit more clean up. I'm not too happy about the mess in between these tiniest components. Okay, that's as clean as it's gonna get. Okay, well now it is time to replace all of the connectors that are here, that are missing anyway. So we have two over here and the third one here. So the one of the pad is gone here, but we'll just have to get creative. I cannot, I realized that I can't reuse original connectors because for the most part they have been completely um, rusted out in parts. So you, for example, let's see if you can find this. You can see that there is a pin missing on this one, and in general quite a bit of rust. And same with this one. So we're not going to be able to use them. I can reuse the other connector because the deferred connector, because that one is in actually a pretty decent shape. I can clean up the rust remaining on here and it'll be good. So to fix this, I have brand new connectors of the same type. As you can see that they're completely clean. So I have a bunch of this. They're gonna go on this sides, and this guy is gonna go here, and then we'll have to fix the pad. Okay, I installed all three connectors. Just need to clean it up. Okay, got some on the other side as well. Okay, well, to take a look. We have everything restored. Everything seems to be in proper state. Brand new connectors, some of the brand new components on here. It's looking really good. Okay, last but not least, while I'm very confident in the strength of all of my jumper wires, I am not going to leave them like that. Plus, we have some exposed copper. Obviously, if we leave that copper exposed like this for extended period of time, there is going to be more corrosion. We cannot have corrosion on a light that goes over saltwater tanks. So what we're going to do is we're going to cover everything in a very thin layer of um, conformal coating or mask. Well, not everything, but just essentially the exposed areas. So this is my my mask that I use. It will serve dual purpose. It will cover exposed area and prevent it from oxidizing, but it will also secure my jumper wires so that they don't move anywhere. This needs to go under UV. Once it's done with UV, it's going to be completely cured and hard as rock. Well, the mask has hardened under the UV. Everything is well protected and covered. There shouldn't be any exposure to the uh, to uh, to the salt or oxygen. This looks really good. And now is the time to test. We'll find out if all of this work actually resulted in something functional. Okay, let's put the Wi-Fi module back in. Okay, let's plug it in. I'm going to give it power. So the expectation is that first, there is not going to be any light because it's not really fully configured. So we'll watch the fan. The fan circuit is supposed to work. It's supposed to spin for just a couple of seconds while I power it on, and then it will turn off because there is nothing to cool. So let's plug it in, see what happens. Oh yeah, the fan is on. The fan is definitely on. And now the fan is off. Now the light is blue. The light is not really configured. Let's see if it will default to some kind of setting. And the light is on. Yes! I think we fixed it. This is awesome. Okay. Well, that should be it. All of the LEDs were on. The fan was working. The light is working. So let's go over again what happened here. So this light had a significant corrosion on the connector board. to the point that most components related to the fan circuit had to be just replaced because they all just rusted away, plus the few connectors that went onto the main board also lost pins and had to be replaced. Quite a few jumper wires had to be run because the pads were also corroded away. So I've replaced missing components, I've restored pads, I ran jumper wires to connect everything together, especially on the fan circuit, cleaned everything up, and the light is working again. Okay, well, that's a success. Well, if you enjoyed this repair, please like and subscribe, and I will see you next time.